couple of years ago, I made this little circuit because I didn't have a dual supply. What it is, I call it a rail splitter. It allows you to hook this circuit, up to a single output power supply, like a laboratory supply or whatever, and it generates a dual supply output. And the only modification that I suggest you make, and I don't remember why I made this modification because I sure didn't make a video about it, so I have no idea what the issue was. But I put a 100 ohm. It looks like looks to be a 100 ohm resistor between the output of the op amp and the ground lead. So, which is actually not a bad idea. I've seen that in a lot of op amp booster designs. And that's what this basically is. You're trying to get a voltage 50-50, between the two power inputs and feed that into your op amp, so it acts like a ground reference. And, you got a potentiometer so you can tune it, tune out any tolerance errors. And then, and that basically sets this up as a class B amplifier, but the end effect is it produces a ground reference that's in between this relatively low impedance. You can see I'm using TIP 3132 transistors on it. And you can see right here, is the circuit. That I built. So there's a little multi-term pot, so you can set your balance point. And again, it's going to divide whatever voltage you put in, in half. So, and it'll work down to a fairly low voltage depending on the operational parameters of the op amp. But the lower the voltage, the more you squeeze the op amp, because it's still, in this case I used a 741. So so it does kind of squeeze it. So you have to observe the operating supply limits, and that'll dictate how well it deals with an imbalance in the load. So because the 741 is going to have 1.5 or 2 volts between each power rail that it can operate in. Well, that's kind of going to be its adjustment range in terms of what it can do with these two transistors and balancing them. The higher the voltage, the more headroom it has. But you can see anyway right now I got the blue probe hooked to the, on the analog discovery here, the blue probe is hooked to the negative supply, and the yellow is to the positive. So, and these are our voltages. Maximum on the positive side is 7.5 and minimum is that. And then I made a little math function here to subtract the two, or really add them, since the one's a negative voltage. So you can see there's about a 40 millivolt difference where I have it adjusted right now. It actually holds that fairly well. And I can show you, too, how it works. So I have my resistor box, and right now I got a load of, just a couple of LEDs hooked to it. So the current's like 7 milliamps. But I can go adjust this load. Right now I got it set to like 100K, so it's not really having an effect. But I can adjust it, down. It's 33 milliamps. Now we got an 89 millivolt load between it, and and I've got, you can see it's 26 milliamps right now. I just switched in another resistor, but I don't want to overload my resistor box by accident. 100 ohms should be safe at the voltage I got it at. But so certainly this is an unbalanced load now, because I only got my resistor box hooked across the positive supply, not the negative supply. You see it does get a little quieter too at this load level, but I can adjust it down. We're at 44 milliamps now, so you can see it get a little noisier on the yellow terminal there, and 162 millivolts. If you look at the peak to peak ripple, you'll see that's that's about the about the same as our error voltage there. So, you know, and it diminishes quite a bit, you know. When I increase the load, we're back down to 32 milliamps now. Let's see, but now let me go to 57 milliamps. So, um, you know, so you can see, you know, what we're dealing with there, you know, a couple hundred millivolts difference. You know, thicker line means it's, you know, got more noise on it, you know, in fact, that applies to the negative rail too, but still, it's not that bad, you know, for, again, a poor man's dual tracking power supply, you know, because that's what this basically is. And, you know, I can even take it up to, you know, 113 milliamps. You can see what it does, but I want to leave it there long. It'll fry my resistor box. So, you know, 113 milliamps, 185 noise volts. See how noisy it is. But yeah, not too much of a difference, you know. And like I said, so you know, that's like 100 milliamp difference between the positive rail versus the negative rail. And again, here it's symmetrical, so I mean, it doesn't really matter. But again, these, I don't have heat sinks on these or anything right now, so I don't want to. And I, you know, I'd have to get my big potentiometer out instead of this thing if I want, because I don't want to damage it anymore, like you've seen in previous videos how damaged it already is from doing shit like this and not thinking about it. But yeah, you know, it's pretty neat. And like I said, you know, I can adjust the input voltage. Well, let me tune this back down first. Okay, so I got it set to 10K, so that's the default load. So that's 7 milliamps flowing through each LED, pretty much. You know, there's not much going through our voltage divider there. But you know, with these transistors, in theory, you know, because you know you're limited to, you know, no more than 36 volts differential. You'll fry the op amp because I don't have any protection on the op amp. In theory, you can make one of these that would operate higher by putting some kind of Zener protection across the power rails on the op amp, possibly. But you could still fuck up the op amp though if you're not careful. But still, I think 10K resistors would provide some good input diode protection for the inputs in case there is an excursion, like a short circuit, you know, or something like that. The nice thing about it is, though, is that, you know, if you did have a short circuit, you know, on, you know, one of the power rails here, you know, it would probably not be, you know, because it wouldn't be a full short circuit because it's still a single rail supply, right? So you'd just be short circuiting, but it would actually make this thing not able to regulate it, obviously. So you would see a drastic change in voltage. You may actually fry your whatever negative circuit you have on here by applying too much voltage across it, perhaps, because you know, basically, you know, if you're short circuiting it, it depends on which way you're short circuiting it technically. So you know, there are issues like that. You know, you could end up, you know, just because of how this thing works, you know, damaging something you have hooked to it if you're not careful. And again, it's for a lab supply, really, and I'd have to actually test that property to see, you know, what the actual output voltages do under a short circuit. I guess that wouldn't be a problem. Let me try it just to see what happens. I'll try to do this real quick. Okay, so basically I got my power supply current limited, and it's good to use something like this with a constant current supply just in case, you know, just in case you do short circuit it, right? You know, that's the whole point. And here, since I got a constant current setting on this power supply, you know, you wouldn't want to, because you could blow these pass transistors out if you didn't have some kind of current limiting, because they are not short circuit protected. So that's just FYI, you know, when you're building a circuit like this. I mean, again, it's a great accessory for a single output power supply, but it's not really a good thing to build into a situation where you may have a variable that causes an unexpected fault and blows out your transistors, you know, because again, these will handle like a few amps or something like that, but and they should, should have a pretty good SOA because of the, voltage being limited to really 36 volts or less, but at any rate, if I, short circuit it, the power supply is kicking in, so you can see that the positive, the yellow line's going to ground, okay, 0 volts, while the negative, is still at like minus 5 volts or something like that, minus 4 volts. Well, you can see there what it's doing before I blow this thing up. But 1 0, the other's minus 3 volts. So that's because when I short circuit, that's what's happening. CCS is kicking in. So, but the point is that I guess that's okay. You don't have to worry. In that short circuit event, you wouldn't blow any chips up or anything. So if you had something connected to it, it wouldn't do. It would do basically what you saw there, as long as it's current limited. So, because it is coming from a single power supply, because that's what I was going to say, is that it'll draw the whole, input rail down, even in an unbalanced load short circuit like I just showed you. That's what I did. I just shorted these terminals together here on my, decade box. So, but yeah, I mean, yeah, it's a handy little gadget, and like I said, I guess it's safer than I was thinking it might be, because I'd never done that test before. Because I kind of built this thing a couple years ago, and I built it originally like you saw in the schematic, so I had to go in and make some modifications because my circuit board design wasn't the best, so I had to take that blue wire and connect it to base, because I put too feeble of a trace going to ground between the two emitters, and so that's where that's coming from. And then then the resistor there is that 100 ohm resistor I told you about, and like I said, here's the circuit board, so basically, you can see this emitter I got connected with this real feeble trace to this emitter. In fact, it's probably in the best layout, but the fact of the matter is that that's where I ran this blue wire from here to ground, because that's so feeble. I mean, I was like, what the fuck am I thinking? It would be better, even though this isn't meant to do a lot of current, still, that's, it's better to have it low impedance as possible instead of through something like that. And then I took the two bases, basically, and connected them to ground too, just to improve the performance of the op amp. I don't know if that was necessary or not, but I can't remember why I did it. That's why I decided to go ahead and make a video. I'd already disconnected this thing, from running some tests on it, and and was happy, and it's like, well, I really should make a video of it, because I didn't do that several years ago. But yeah, at any rate, let me, I'll change the voltage supply here so you can see, how it rail splits. So you can see that, we got like a, 7 millivolt difference, with equal applied loads here, but, at 23 volts input. So, and you can see what the voltages are doing, plus or minus 12 here at 25 volts. So it actually splits it right in the middle. It's because the op amp's doing it, taking care of it and making sure it's balanced. So, so if you were just actually taking the output from an op amp, you wouldn't get 25 volts, total voltage out of it. You wouldn't get 12.5 volts per side. You would get something in between that. I mean, you probably would actually. I mean, if you're taking it, just from an op amp. I mean, for an op amp, yeah, if you balance it, you can get some up to maybe 10 milliamps of current or something like that by doing the same thing with the op amp alone. But you kind of, because it is an op amp, you wouldn't be able to, you wouldn't expect to see it fluctuate rail to rail, but that's because your output is actually between the rails. So the op amp is operating kind of in a nested fashion. If you drop the two voltages, the positive voltage by a couple of volts and the negative voltage, you increase it by a couple of volts, that's the range the op amp is operating over, because it's got that voltage drop on each rail. So, it was, a little surprising until I thought about it, that, hey, this is actually splitting the power supply. Now, of course it is. That's what it's meant to do. But anyway, because I didn't even know what this fucking thing was at first. It was just in my junk box. I had to look it up and make sure I was looking at what I thought it was. So I've forgotten all about it. But yeah, I mean, like I said, taking up to, 32 volts, and you can see our outputs plus or minus, 15. But, about plus or minus 16 really. There's a 40 millivolt difference between the two. But going the other way, you know, you can see we're down to 7 volts where we were when we started the video. Now down to plus or minus 5 volts. Now I'm not sure what the operating limits on a 741 are. I don't know if it's 4 volts or is it 8 volts. Plus or minus 4 volts or is it 8 volts? I'm not sure. Got it to 9 volts right now. I took it down to 7. It gets, noisier, and our differential is getting higher, as I lower the voltage. But, so we're putting out, plus or minus, it's about 7 volts is where I got it set. So, but at any rate, you can do your own experience. It's a simple little circuit to make. So, it's, pretty easy to cobble together. So anyway, I just thought I'd document it so I don't make the same mistake I did several years ago. Because, I might go ahead and actually put this in a box or something. Because, there are times, one of the nice things about this fucking thing is this. I got this little button, right, and I can turn this off or on. But, when you got a dual power supply with no button on it, the only thing you can do is that. And, with something like this, you could put your own little switch there and actually turn this thing off and on, if you didn't have one of these little control buttons. And that allows you to do that with a dual power supply, because that's something that always makes me nervous, is these power supplies, hooking the thing up, and, hooking the thing up and trying to see what the, which rail, especially if it's live, which rail do you connect first? So it almost invariably means you got to turn the switch off, and then you got transformer surges when you turn it back on. You're always kind of wondering, well, is the voltage really going to be where you set it? That kind of thing. It's nice to have an on power supply and just be able to switch your load off and on. And like I said, you can do that with a, by putting a little switch here, a little toggle switch or whatnot. And that kind of gives you the same benefit, so you can turn this on and off without turning your power supply on. It's one of the big things I do with power supplies. It's a critical piece of test equipment. And anytime I build a new circuit, you always do a smoke test at first, which means you usually try to start at a low voltage and current limit it, and then just kind of slowly build it up and look at the current ratings. That's why I like a current that reads down to a milliamp, and so you can really monitor that to see if anything looks off before you as you start to apply full power. But that's hard to do with, if you don't have a dual tracking power supply. It is hard to do that with a, if you just have two like regular power supplies strung together. It's hard to freaking be able to adjust that voltage and current simultaneously. This allows you to do that. I mean, you can adjust the voltage and current simultaneously on the things, and adjust it as you slowly start to test it. So you can not only put a switch on it, but you can also use a single supply in its facilities, to essentially do, what otherwise you need a dual power supply for. And that one, great though it is, it doesn't read down to the milliamps, so it's still, I don't feel as comfortable burn-in testing with that as I do this, because sometimes shit can go wrong at, oh shit, that shouldn't be drawing 8 milliamps, you know what I mean, at this level. I should look at it, there must be a fault. Well, I couldn't get that indication from that until I really kind of started jacking it up. So, but like I said, that's why it's just a neat little thing. And if you wanted to make this resistor variable, like an actual panel mount potentiometer, one of those multi-turn ones you can get off Amazon would be maybe suitable. Although it's wire wound and kind of coarse, it may introduce some noise into it. I don't know, but probably not if you had it kind of limited. But then you could actually make the thing so that, you could actually adjust the relative voltage levels too, and it would still be dual tracking, but I could set, the upper half to 5 volts and lower half to 10 volts, for example, if that's what you wanted for the circuit you're testing, and then adjust the master, and it should keep that proportion. So that's something that would be difficult to do. Even with that thing, if I set it up as, two independent supplies, they'd be basically independent. So, but you could do something like that with this that I could not do with these other power supplies. Set them to a proportion of the load. Then you can burn in your test like that, because sometimes you might need 12 volts on the positive side and like a negative 5 volts on the negative side, to try to make a voltage regulator you're building so that it goes down to ground like a 317. You need a negative voltage to trick it to go down to 0 volts. Otherwise, you're stuck at 1.25 volts above ground. And by the way, you can make any regulator work kind of like a 317 pretty much. It's just they're noisy, like a 7805. You can actually do some of the same things. You can make it variable, like you can 317, but you just can't go down below 5 volts. But you can still use that same technique to make it go down below 5 volts. And you can see these if you look at regulator data books. A lot of them, from different manufacturers, they have different example circuits. You'll see some interesting stuff in there on those 3-terminal regulators. But at any rate, I'm just saying, it's actually a pretty useful tool, and I hope I'll, consider some of my own advice there. It might be worth building another version of this that, has a multi-turn center pot. But, you could have a multi-turn pot and then switch that out, with another little switch, and then just have your center version that you have here as an alternative VREF point. It's conceivable you can do that. You'd probably have to switch the reference between 2 different voltage dividers to do that, but with a double throw switch or whatnot. But at any rate, it's actually a pretty useful little gadget. So yeah, I may actually take this seriously as just because I can put a switch on it, nothing else. Because I really didn't think about that until I made this video, because none of my other power supplies have that neat little switch. And I'll tell you what, I only paid $50 for this thing, but boy, that alone made it worthwhile. I thought it was a little silly at first, but boy, it just really sucks having to turn the supply off and turn it back on, because switching something on usually is hard on it. And so if you have to switch on and off your power supply all the time, it's going through power supply surges. Even if it's SMPS based like that is, it's still going to have take its toll on the circuitry every time you do that. It's nice to not have to do that. And again, it sucks. Nobody likes being blind. When you turn it off, you're blind. Okay, so is it really going to do what you think it's going to do when you turn it back on? Especially with a SMPS, out of China or whatnot. Who knows? So anyway, it gives you more certainty. But at any rate, yeah, I thought I would cover that. I thought this was going to be a video just for myself, but I don't know. You might find it useful. So anyway, cheers. But yeah, I'm one final word. I'm glad, because those 2 ideas. I didn't, I honestly, like I said, I'd taken this thing apart and and was setting it aside because I didn't really need it anymore. So I really wouldn't think about even looking at it anymore. But no, there actually is a need. And again, I didn't think of either of those 2 ideas. The external potentiometer and the ratiatic proportionality. Or the switch. But yeah, I might build this up into a new project, maybe even build a couple of these. These could come in handy in a number of different places for that reason. At least have one, that does what I described in this video. So yeah, I'm really glad I made that, because otherwise, yeah, I was done with it, ready to move on to something else. So anyway, cheers.